Meeta, thank you for joining. I'm really looking forward to this. For those who don't know Meeta, I'm going to give her a brief introduction, and keep in mind that these videos will be sent to everybody after we have a chance to edit them. So if there's something that you missed, not to worry, we'll be sending this out to the folks who have joined here and our wider audience. So I'm really looking forward to this one. And Meeta, if you're not familiar with the work that she does, she's very passionate and customer-centric product leader. She has a track record of launching innovative products that solve real business problems. And as VP of product at Verta, she's currently building MLOps tools to help data science teams track and deploy and operate and monitor models and bring AI and ML and bring order to the AI and ML chaos that currently exists and many of us are experiencing. Prior to Verta, Meeta held several product leadership roles at Appen, Figure 8, Cisco Systems, TalkBox, which is Telefonica, and computer associates building ML, various computer associates building ML, data platforms, voice or conversational AI products, and IT or operational monitoring tools. So with that being said, I am very pleased to welcome Meeta, and I will get off screen. And just as I mentioned, if you have any questions, feel free to pop those in the chat and we can get to those afterwards. Okay, Meeta.
Thank you, David. Hi, everyone. I'm really glad that we are discussing this topic today. I'll just quickly share my screen and get started. Hopefully you all can see my screen now. So the topic for today is simplifying AI DevOps with Model Registry. And again, appreciate your time today, and I'm looking forward to the discussion. I think David has covered my background, so I'll just quickly introduce myself that I head product at Verta, and really excited to talk about MLOps and the problems that we are facing and the solutions that we are looking at. The agenda for today's session is really the following. We'll briefly talk about the current challenges around operationalizing machine learning and AI products. And I'll be comparing it with DevOps and the typical process that we follow with software. And we'll see the similarities and dissimilarities, the differences between MLOps, DevOps, the way we build machine learning versus we build software, and just learn from those best practices and build something much better. And we'll talk about the why, what, and how around model reproducibility, making the model more portable and streamlining the release process. But all this from a lens of a model registry. We'll have a quick demo and followed by Q&A. So moving on, I have launched a lot of AI products in my past and have worked with a lot of data science teams launching interesting AI products, and they're in different life cycle or different levels of their AI maturity. But what we've seen in last couple of years is the problem space has changed. A few years back, teams were struggling with building AI algorithms or training them, but now we have more or less solved that problem. So we are in a much matured stage when it comes to model building and model development. But where teams are now struggling is when it comes to actually operationalizing them and running them at scale in production. And these are some examples that we have heard from a lot of data science teams. This one is it takes us 20 plus weeks to bring a new version of the model into production because deployment and release process is somewhat broken. We do not know which models exist and who is using which models. There are teams who are struggling with this problem around that we have half a dozen different ways of building models and so many places to run them. And the models call each other, so there is a lot of interdependency, but we have no central place to get the visibility of all the models at an org level. And if you look at all these problems, we can sum it up into a couple of areas. The first one is now we have a lot of teams within a particular company running ML initiatives, and we do have options for different tools. We have so many different frameworks, so many different tools, which is great for innovation, but it comes with some challenges as well because it becomes hard to manage and hard to govern. The next challenge is around operating and running models is sometimes out of scope for data science teams. Data science teams are really good with building models and algorithms, but someone needs to operate and run them. And in many cases, teams kind of build one-off solutions, which creates more problems, and it kind of slows down the model deployment process, creating more frustration for data scientists. And last but not the least, there is this whole notion around losing control and visibility of where and how models are running, because of the fragmented approach to operationalizing them. So that kind of creates organizational silo, which is not something that that's good for future growth and adoption. But we do not have those challenges in typical software development. So if you look at DevOps process, the goal for DevOps is delivering software products faster and in much more reliable fashion. And if you look at the life cycle, all of you would agree to this life cycle, right? So we start planning, we create, package, release, configure, and monitor. That's a typical software development life cycle. And in today's world, we are in a much better stage when it comes to managing the DevOps tools and processes, because we do have really matured tools like Jira for planning. You may be using Git for your version control. You may be using Docker or something similar for packaging, Jenkins and Chef for your CI/CD pipeline, and then finally monitoring tools like Grafana or Elastic or Datadog. So again, this is a very well-defined process for DevOps. But if we flip the coin and look at MLOps, again, the goal for MLOps is delivering ML products faster and more reliable. And if you look at the state of the art, we are still struggling in a lot of the phases. I think I briefly touched on the concept that we kind of have somewhat solved the problem around model development. So there are a lot of frameworks and a lot of things that helps us with model development and in this phase. But as we move down the life cycle, we do see a lot of gaps, and folks are creating one-off solutions, which kind of adds to the problem. And I assume all of us are here talking about MLOps because we recognize that this is the place which is broken and we need to solve it. And our ideal goal is to achieve a level of maturity that we have with DevOps, or even better. So again, when we talk about MLOps, it's a much bigger space, and there are a lot of different moving parts. I'm not going to touch on everything. What I'm focusing on right now is about Model Registry. The goal here is to create a central unified repo for all your ML models, so you can track all your machine learning models, all their key artifacts, and create a kind of a unified view of what's happening around your ML initiatives. And this is super critical in the entire MLOps lifecycle, because it kind of creates that central synchronization point for all your models that is being built. And it kind of, when we go through this presentation, we'll discuss about like how it impacts different stages, and more importantly, your release and post-deployment processes. So let's look at the first problem area. The first one is how data scientists develop a model and how is it deployed. A typical ML release process may look like this. The data scientist is, as a data scientist, you are iterating and running multiple experiments. You may be running tens and hundreds of them, improving your model. And then when the model is ready and you think it's something acceptable to be deployed, the data scientist just throw that model off the fence to a software engineer or a ML engineer. And that person needs to figure out how the model was built. They need to package it. They need to understand all the details of the model, and finally deploy it. And this is where things break down. And then because because there is no collaboration, no way for folks to understand and work with each other and iterate on a model, the deployments, and that's the reason why teams face a deployment cycle of months or quarters. In the ideal world, how we can do it is the data scientists keep iterating on the model. When they think that a particular model is ready and they have a great accuracy that they're looking for, they put that model in a staging place. So you are staging it in a registry, and that's where registry comes into play, where you kind of stage your model. It's when you are staging your model, it's just not the model code, but all the associated information. Think of it like you are exposing all the API contracts. So when an ML engineer or a software engineer is taking the model to production, they have all the necessary information about the model, and you are not working in silos, but you are working in a much more agile fashion because the data scientists are iterating and these guys are taking the model into production in a much more transparent manner. And that's why parallel development and staging really helps fast track the development process, and a model registry can help create that kind of transparency and cross-team collaboration. The next problem that I want to talk about is even if you kind of stage your model, there are other problems that comes with machine learning. What we have seen is ML models are very finicky and very brittle, right? So even if you have the same model, it can produce widely different results when we change. Maybe there's a change in the infrastructure, if the underlying libraries change, or even the environment variables change. And when it comes to real world, we all would accept that the development environment, your QA, integration, production, depending on how you move your code when you're deploying, the environments vary a lot. So this adds additional layer of complexity when it comes to machine learning. And another problem here is you are a data scientist when you develop a model, even if it's works amazingly well in your dev environment, it doesn't run on its own in production. It may be working with a existing product experience. Maybe if you're building a search recommendation system, it needs to work with your other product areas. And what we have seen is when those models come from dev environment to when it gets integrated into the product ecosystem, a whole host of problems come into play. Sometimes the model is not performant enough, it's too slow, it shows some error, the accuracy is very different than what the data scientist claims to have. So these problems kind of crop up a lot that kind of significantly slows down the deployment process. And we have heard horror stories from teams who have spent weeks figuring it out why a particular model is giving different predictions between dev and production. If everything is there, everything looks same, but why is it behaving so differently? And this happens because ML model development is very different than software. It's very empirical and ad hoc. So you start with one model. You may you may look at like the accuracy, which maybe let's assume it's the first iteration that gives you 60% accuracy. And then you start adding a new feature. You try with a different training data set. You start doing hyperparameter tuning. And after a couple of iterations, your model code and your data looks nothing like what you have started with. So that's the reason it's very important that you kind of keep track of all the model iterations and make the model much more reproducible. So as long as you can make the model reproducible, some of these problems that we discussed here, like model being finicky and when you're moving from dev to production, it behaves very differently, could somewhat be solved because you can give the exact reproducible model that someone else can take and put it in the production environment, creating a very similar behavior. So again, going back to the point that model reproducibility is critical. How do we achieve reproducibility, right? What artifacts do you need to make models reproducible? If you look at software, we start with source code, then we create binary, and then we package it. And everything can be tracked to the source code. So if something breaks down in production, you can go to a specific version in the code and you know what code exactly is creating a particular behavior. But when we talk about machine learning, it's just not the code. What we have seen is there are a couple of other ingredients that kind of impacts how your model behaves in certain way. That includes code, the data that you have used, any kind of environment variables, as well as all the configurations. When I say configuration, I mean things like hyperparameters. And environment variables is all the dependencies and all the libraries that you're using. And your model will behave very differently if there is a slight change in a version of a particular Python library that you're dependent on, or if you're using a different training data set. So again, you have to bring together all these different artifacts to actually create a particular version and reproduce the exact same behavior. And that's why it's machine learning models are a bit different than software. So the version control needs to adapt accordingly. So how do you build a better reproducibility, and what kind of version control architecture would really work in this scenario? What we've seen is Of course, you can create a robust version control only for models. But in reality, you may have, as an organization, you may have your code in Git, and that is used for your code version control, which is great. So you have your code repo. You may have your data repo somewhere else. For example, if you're using some kind of cloud service, if you have a specific ETL pipeline and a data platform, you may have your data staying there. But at the end of the day, what you need is a singular place where you are taking a snapshot of your data repo, your code repo, all your configuration and environment variables for a particular model version. And you're keeping all that snapshots that is tied to XYZ model version. For example, model A V0 is tied to this version of your data repo, this version of your code, config, and environment. So when it comes to reproducing the model, you have the exact information of what is being used to create that model. And that is extremely important, not just for helping you in the release process, but even down the line when there are any production problems when you're debugging. The other problem that I want to highlight here is in that kind of sometimes slows down the release process is risk management and model governance. If you're in banking or a more regulated industry, you can understand the pain point here. But in general, what we are doing right now is we are using machine learning to build and create models that are making a lot of nuanced decisions, like credit approval, figuring out whether someone is at fraud risk, or detecting disease in healthcare. And that means that you cannot just blindly deploy a model in production if it is making more high-risk decisions. And you need approvals and some checks and balances on the way. And those checks and balances, in some cases, are not just coming from your technical peers. It may be coming from your legal team, your compliance, your teams who are worried about data privacy, teams who are thinking about whether there is a bias in your model. So again, creating that kind of custom approval workflows where you are involving folks in the process and getting their approval in a much more automated way also significantly fast tracks your model deployment and release process. And you're also creating that organizational transparency. And I also want to highlight one thing here, that we have to balance between creating more custom approval workflows versus speed and time to market. So you can create different risk levels of your model. So for example, if it is a high risk model, you have a more controlled release, versus if it's a low risk model, we can just push and deploy it in production without any approval. So again, it depends on your use cases, but within an org, you may have different risk levels and categories and create different custom approval workflows. But at the end of the day, all this information should be somewhere where in a registry where everything is tracked, all the models that are staged are tracked in a unified place. You have all the model artifacts, the data that is used to train the model, all the associated documentation. So folks who are reviewing and approving it have everything handy. And that kind of fast tracks the development process. Instead of going and handing over a model to someone else to review in a haphazard and one-off way, if you create this kind of automated registry and approval process, everything will be much more transparent and much more faster. So hopefully that gives you some idea about the pain points and how model registry can help. I want to draw the analogy of Docker Hub here, right? When you're thinking about simplifying model release and creating more org-wide transparency, we can think about how we have used it in Docker, right? We have Docker Registry that helps developers just build their code once, and they can publish the images, and anyone can just take that image and run independently. And they can tag different versions, create different iterations, but everything is tracked in a unified hub, and all the peers, like the QAs, the DevOps guys, everyone is kind of looking at the same source of truth. And it's really important that we kind of learn from these best practices. And the model registry is a variation of Docker Registry or Docker Hub, but more geared towards machine learning models. So it can provide a similar level of interoperability and all the information about the model and a transparency that folks are looking for. And again, irrespective of where the model is running, you may be running your model with different cloud providers. You may be creating different types of models, maybe a computer vision model, NLP model, a model for your risk management, model to identify churn, but everything is tracked in one place. Anyone can go and look at a model and recreate the same behavior whenever they want it. And this is the kind of best practice that we need to instill. And Model Registry is the best way to do that. So hopefully I kind of convinced you that Model Registry is important and why. Again, just to recap, it helps streamline and the development and staging process. It also ensures that you have enough information about the model artifacts and all the information about like how the model is built. So it's much more reproducible and it's transparent for the company. And you can easily manage the model lifecycle from development to production to end of life. And also you can ensure that you are introducing more governance and approval workflows as part of the Model Registry. Next, I'll go and have a quick demo. In the interest of time, I'll move faster, but hopefully we can cover some of these areas around how to instrument your model code to be reproducible. Then we'll talk about tracking all your experiments in a centralized view and create a model registry. And I'm using a Model DB, which is an open source framework that we are using for, we built for model experiment management and version control. I'll use that as an example and also show some features that are not fully open source around Model Registry, but it's a combination of both open source tool as well as something that we have built for our enterprise customers. So the example that I'm taking here is a census example where we are building a model, a logistic regression that looks at census data, a lot of information about people and kind of predicts what is your income level. And this is a notebook, a simple notebook, that Jupyter notebook, but you can start logging information from any of your like model development framework. I'm just taking this for simplicity. And we start with setting up a client. So here what we are doing is when you're running or training your model, you have to use a library, which is it's a Python library, very lightweight library that you can use that can help you log and instrument all your model behavior. So this will start with just importing the library. Then we'll provide some information about the project and experiments and your environment like email and access key. And here what happens is when you start logging the information, it's logged to a web app where you can go and visualize all the information. Again, you have the option to use APIs and CLI interface as well. If you do not want to use web app, but you do have all the options. So you have APIs, you have CLI as well as a web app to take a lot of these actions. And here you are importing all the dependent libraries. And the next stage is model development. And in the model development, the first key thing is preparing your data. So again, I want to bring this concept we discussed about creating a better version control for the data. So here we are talking about Amazon AWS. So you can store your data any place. I'm just using AWS as an example. But the idea is you can go for and store your data any place. But ultimately, we'll version control the data, and you can go back and look at the snapshot and say and find out, okay, this is the exact training data and test data that I have used for this particular model version. And just for just show you the example, this data has all these columns, which is information about a person, their education, their employment qualification. And at the end, it's creating the prediction, which is the last column, which is whether their pay is more than 50K or not. That's what the prediction will happen. That's how. The next step is preparing hyperparameters. So you're iterating and doing some hyperparameter search, and initiating the client, which is the Verta client, which is the Python library. And this is where all the interesting things happen when you are training your model. You are splitting your data, training and validation data. You're logging all the hyperparameters and logging all the metrics. And here we have logged accuracy, but again, whatever metrics is important for you, you can start logging them. You're logging your deployment artifacts. So this is really important to recreate the environment variables. Then you're logging your model and your data set. So I just ran this already, so you can see that everything has been done successfully. So I'll just quickly go to the web app to see how this looks. So this looks like once you log this information in the web app, a project will be created. And this project will track all the experiments that you're running and the associated experiment runs. So the data scientists can look at multiple experiment runs. They can, filter, sort them based on specific metrics. They can look at the hyperparameters. They can go and compare multiple experiment runs to see the differences. In this case, there is a difference in hyperparameters. And the accuracy is this has a lower accuracy. This particular iteration has a higher accuracy. The artifacts have changed a little bit, so they can track all the differences, and then finally figure out which model really works best for them, and quickly register that model from the web app. But we can do it from the Jupyter Notebook with a CLI interface as well. So here let's see how it works. So you can retrieve the best run. So you've run hundreds of experiments. So you can say, okay, what is the best run? So in this case, the run with accuracy of 0.7992 seems to be the best run. Then you can train with your full data set and then look at the accuracy. I'm not running that, but this is where the development ends. This is where the data scientist is done developing the model, and then they go and register. So we will register the model. And the model is reflected in a model registry. And we are creating a new version. So when that model registry action happens, you move from development to model registry, which is an in-between step between in your production environment. And here you can see all the registered models that is running within your organization. You can look at their risk level. And this is the model that we registered, but we'll look at a previous model that we have added to the registry. And this kind of, you can add, there is a readMD option, so you can add more documentation about the model. You can create different versions. So here, the first version is has been approved. It's already running. And V1 is in development. If you go to a particular version, you can look at the life cycle. So this has been approved. And all the package, Docker package, all the artifacts, as well as who has approved when. So you have that audit log as well, along with a lot of information. So again, creating this kind of model registry view is really important, because you are easily moving from development to registry, and you can then deploy. So you kind of have a unified view of all the models in one place. Hopefully that gives you some idea of how it's done in ModelDB and Verta. But again, this kind of framework can be created and architected depending on how you what's your preference. But whatever I've demoed, you can try it yourself. Again, ModelDB is completely open source, so you can go and fork it in GitHub and try playing with it. The other option that we have is we've created just launched a hosted free trial. So you can go to www.verta.ai/trial and play with most of the features that I shared that we have with ModelDB, as well as the ability to register a model, deploy, and monitor it in production. So feel free to choose either of the options and give us your feedback. Hopefully this made sense to you, and if you have any questions, please let me know. So I'll be here for the next couple of minutes, and if there are any questions, you can put it in the chat window.
And thank you very much, Meeta. I appreciate you sharing that talk and demo walkthrough. Yeah, if anybody has any questions, I'll let you answer those. Otherwise, thank you very much. I really appreciate it.
Awesome. Thank you. I'll stick around for a couple of minutes. So I don't see any questions. So I think we are good for now. But again, I want to repeat the same thing that I just mentioned. Like, you can go to the ModelDB in GitHub and fork it, and even I would encourage you to join the open source community, and you can collaborate with your peers and ask questions to Verta team. So I'll be happy to work with you. Again, thank you for everyone's time.